Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video in Engineers in Progress. I hope that uh, you will find this interesting and important in your studies, thereby improving your thinking skills in math, which is more important in your preparations about geometric problems. So this is the continuation. The John Hancock Center in Chicago has a rectangular base. The length of the base measures 65 feet, less than twice the width. The perimeter of the base is 860 feet. What are the dimensions of the base? So we will call the length of the base as B and the width as H, just like before. So it is stated here that the length of the base measures 65 feet, less than twice the width. So that means B is equal to 2 times H minus 65. And since perimeter is 2 times quantity B plus H, we replace B by 2H minus 65, substitute perimeter 860 equals 2 quantity 2H minus 65 plus H. So 860 divided by 2 is 430 equals 3H minus 65. So that means 3H is equal to 430 plus 65, that's 495. So 495 equals 3H. So solving for H, 495 over 3, the width is 165 feet and the length of the base is 2 times 165, 330 minus 65. So that would be 265 feet. So that's the length of the base. Problem 9. The John Hancock Center in Chicago, so continuation, tapers as it rises. The top floor is rectangular and has a perimeter of 520 feet. The width of the top floor measures 20 feet, more than one half its length. What are the dimensions of the top floor? So still on perimeter, which is 2 quantity B plus H. This time, the width of the top floor, so H is equal to 20 feet, more than one half its length. So if the length is denoted by B, then H is equal to one half of B plus 20. So H is one half of B plus 20. Substitute into perimeter equals 2 times quantity 2B plus H. So 520 equals 2 quantity B plus B over 2 plus 20. 520 over 2 is 260. And this is 3 halves plus 20. So 240 minus 20, 240 equals 3 halves B. So B is 2 times 240, 480 over 3. So B is the length of the top is 160 feet. And H is 160 over 280 plus 20, so 100 feet. That's the width of the top. Problem 10. The Bermuda Triangle supposedly causes trouble for aircraft pilots. It has a perimeter of 3,075 miles. The shortest side measures 75 miles less than the middle side, and the longest side measures 375 miles more than the middle side. So find the lengths of the three sides. So to make the solution simple, we will denote the shortest side as S, and the middle side would be S plus 75, and the longest side would be middle side, which is s plus 75 plus 375. And we equate the sum to 3075, the perimeter of the Bermuda Triangle. So s plus quantity s plus 75 plus quantity s plus 75 plus 375. This is the middle side. Middle side plus 375, that's the longest side, equals 3075. So adding 3s 150, 3s plus 525 equals 3075. So 3075 minus 525, 3s is equal to 2550. So from here we can solve for s to 2550 divided by 3. So s, the shortest side of the Bermuda Triangle, is 850 miles. Then 850 plus 75, that's the middle side, and that is 925 miles. And finally, 925 plus 375 is 1,300 miles. (925 plus 375) or S plus 450, that's 1,300 miles. That's the longest side. Problem 11. The Vietnam Veterans Memorial in Washington, D.C. is in the shape of two sides of an isosceles triangle. If the two walls of equal length were joined by a straight line of 438 feet, the perimeter of the resulting triangle would be 931.5 feet. Find the length of the two walls. So the length of the two walls are equal, forming the sides of the equilateral isosceles triangle rather. So we will call that x. So 2x plus 438 equals 931.5. So that's the equation. 2x, 2 times the length of the equal lengths of walls, plus 438 equals 931.5. So 2x equals 493.5. So x is 493.5 divided by 2, and that is 246.75 feet. So that's it for this problem 11. Let's proceed to problem 12. A square has perimeter 80 centimeters. What would be the perimeter of an equilateral triangle whose sides each measure the same length as the side of the square? So the perimeter of the equilateral triangle is 3 times one of the sides, because an equilateral triangle has 3 equal sides, and the perimeter of the square is 4 times the side. So 4 times s, we'll call s the side of the square, which is also the side of the equilateral triangle as stated here, equals 80. So s equals 20 cm. Therefore, the perimeter of the equilateral triangle is 3 times 20, and that is equal to 60 centimeters. Problem 13. Suppose that you know the two angles of a triangle have equal measures, and the third angle measures 36 degrees. Determine one of the measures of the equal angles. So this is an isosceles triangle. We will call the equal measures of the angles as the equal angles, the measure as x. So 2x plus 36, and we know that the sum of the interior angles of a triangle is 180 degrees. So we equate 2x plus 36 to 180 degrees. So 2x equals 1 is 72 degrees. 180 minus 36 is 144 degrees divided by 2. So x equals 72 degrees. Problem 14. Find the measure of each angle in the triangle shown. So we know that the sum of the interior angles is 180 degrees. So we add these angles, 9x minus 4 plus 3x plus 7 plus 4x plus 1 equals 180 degrees. So 9x plus 3x, 12x plus 4x, 16x. Negative 4 plus 7 is 3 plus 1, 4. So 16x plus 4 degrees equals 180. So we'll just denote the unit later. 180 minus 4 is 176 divided by 16. So x is equal to 16x equals 176. So x is equal to 11 degrees. Having found x, then the measures of the angles would be 9 times 11 minus 4. 99 minus 4 is 95 degrees. Then this angle 3x plus 11, 3 times 11, 33 plus 7 is 40 degrees. And 4x plus 1 is 4 times 11, 44 plus 1, 45 degrees. So adding these angles, it should be 180 degrees to check. Problem 15, find the measure of each angle in the triangles shown. So adding again and equate to 180, 2x minus 120 degrees plus x minus 30 plus x over 2 plus 15 equals 180 degrees. So 2x plus x over 2, that's 7 halves x. Negative 120 minus 30, negative 150 plus 15, negative 135. So 7 halves x minus 135 equals 180. So 7 half x equals 315 degrees. So x is equal to uh, 2 times 315 over 7. So that's 90 degrees. Therefore, the measure of the angles, 2 times 90 is 180 minus 120. This is 60 degrees. So that's 60 degrees. This angle is 90 minus 30. So 60 degrees also. And this angle is, the measure of this angle is 90 over 245 plus 15. So it is also 60 degrees. So this triangle is an equilateral triangle. Then lastly, problem 16, but we'll have more geometric problems in the next video. Consider the following figures. Solve for the measures of the unknown angles in figure 1. Solve for the measure of the unknown angle y degrees in figure 2. And add the measure of the two angles you found in A. That's part C, and part D. Make a conjecture about the relationship among the angles marked theta 1, theta 2, and theta 3 in figure 3. So here is the given figures 1, figures 2, and figures 3. So for figure 1, the sum of the interior angles is 180. So x plus 2x plus 60 equals 180 degrees. 180 minus 60 is 120. 3x equals 120. So that means x is 120 over 3. So x is 40 degrees. So this angle is 40 degrees. 2 times x is 80 degrees. And the third angle is 60 degrees. So part B, solve for the measure of the unknown angle y. Since 60 plus y form a straight line or straight angle, and straight angle is 180 degrees, so 60 degrees plus y degrees equals 180 degrees. So that means y is 180 degrees minus 60 degrees. Again, 60 degrees to the left plus y is 180. So that's why y is 180 degrees minus 60 degrees. So y is 120 degrees. Then letter C, if we add the angles x and 2x, 40 plus 80, that's also 120 degrees, which is equal to y. Because that is supposedly the relationship. So for part D, here, this angle is supposedly 180 degrees minus theta 1 minus theta 2, this angle here. And the measure of this angle added to theta 3 form another straight angle which is 180 degrees. So again, this angle 180 degrees minus theta 1 minus theta 2 plus theta 3 equals 180. So 180 degrees minus theta 1 minus theta 2 plus theta 3 equals 180 degrees. So we can cancel 180 degrees, transpose negative theta 1 and negative theta 2 to the right. So that means that theta 3 is the sum of these two angles here. So theta 3 is equal to theta 1 plus theta 2 degrees. So that's it for this video, and I hope that you learned little in engineering. If if you are good in engineering, these problems would be very, very light, and engineers are already good at it.